artificial intelligence has become a part of our daily lives. It has become so general that we don't even realize that we are using it on our day-to-day basis. And not even in our daily lives, it is also impacting the industries. Right from the consumer-based companies to the manufacturing industries, they have all become heavily dependent on the artificial intelligence to improve their productivity or to optimize their resources. So today I'll be talking about how AI is revolutionizing paper mills to achieve optimization and sustainability. So quickly I'll give you an overview what is the brief agenda. So we'll be quickly talking about the energy scenario and what's the need of AI in the paper industry and what's the method, like how it works and what it does. And then finally we will get into the case study which will talk about what is the use of AI in paper industry and what's the paper's approach to the process and what parameters we have considered in building this AI-based model, finally the key results and conclusion. So as we talk about the energy consumption in the paper industry is among the 5 top consumers of energy. And if we specifically talk about the paper making process, it has to be the drying process which accounts for around 70% of the total energy that is being used in the paper making process. And if we look at the scenario, it becomes a strong business need to invest in energy efficient projects as this energy accounts for around 15 to 20% of the total operating cost. In these kind of situations, specifically, technology has been of great help. With technology growing over the years, it has helped in reducing the energy consumptions in several industries. So let's talk about why do we even need AI in the paper industry. So the first and foremost thing is being a part of paper industry. We have all used, We have all used Excel or MATLAB to build linear regressions to understand how one thing correlates to another and take decisions based on that. But paper making in general is a very complex process. You cannot understand that of just judging that or based on the linear relationships. In these cases specifically, AI really starts to shine because it understands the complex nature of the pulping process or the paper making process, and based on that, it takes much more accurate and quick decisions. Now, another issue that we have in the paper industry, it has to be the manual testing process, because in general, it takes around 45 minutes to 1 hour or sometimes even longer to get these tests done. And once these tests are done, then only we can make adjustments in our process, maybe the process variables or the chemical dosages, anything. But paper making is a continuous process, right? So based, in any case, either we run with excess strength or excess chemistry because we cannot wait for an hour to get the test done, and it will get our cost increases. So in these cases also, artificial intelligence kind of helps because it understands, it takes all the processes, all the variables that we are, all the data that we are collecting in the paper industry, and once we have all that data, AI do the analysis based on the machine learning technique, and real time, it calculates the real time data for these key parameters, and once we have this data on a real time basis, it becomes very easy for the operators or the management to take decisions based on that. Now we have talked about the gaps. So what is the solution? So solution, if we talk about the solution, we have Alexa, which is basically our artificial intelligence machine learning device, which basically works on all the different prospects, maybe the mechanical, chemical, or the operational aspect. And what it does is it basically does the real-time sampling of the critical variables. So now what's the need of this real-time sampling of the critical variables? See, if we are going for any process in the paper industry, let's say you want to automate refiner management or the strength improvement, there will be certain critical variables that we are not measuring on a real-time basis. So what Alexa does is it measures those critical variables through sensors on a real-time basis. Now, once we have this data on a real-time basis, maybe through the sensors and through the historian, it collects all the data, and based on the machine learning technique, it predicts these KPIs or the key parameters on a real-time basis. Now, once we have these KPIs on a real-time basis, what we can develop or what we develop and implement is an autonomous control process by which we can actually predict the dosages or predict the process variables in real time. So it will be basically a closed loop control process entirely. Now once we have developed the model and implemented it, we can actually visualize all these data and the KPI evaluations on a dashboard, which can also be accessed remotely. Now coming to the case study, so AWARE has conducted a case study at one of a paper mill where the main issue was with the drainage issue and which was impacting their overall energy consumption and the power consumption. Now the objective here was to increase the production rate, reduce the energy consumption and basically improve the overall machine width and stability. Now what Haber felt was to achieve these objectives, the best suited program to implement at site was RDA automation. So to achieve that optimal this retention and drainage through AI-based program, what we have done is we have fetched 3 months of data for the variables that are critical for the key parameters, which I would say is first pass retention, first pass ash retention and drainage. Now once we have all this data through the sensors and through the historian, it predicts the FPAR and FPR on a real-time basis. So when we have these key parameters on a real-time basis, once we have this FPR and FPAR on a real-time basis, we will be predicting predicting the dosages of the coagulant or the retention chemicals on a real-time basis. So it will be a full-on closed-loop control system. Now coming to the variables that we have considered in building the model. So let's start from the data that we have collected through the historian. So the first one is the grade and GSM, which is because generally the KPIs vary with the grade and GSM. Because if you want to develop a grade specific model, the grade becomes of prime importance. Other than that, we are measuring data for production rate, vacuum box pressure, press load and steam pressure. So free drainage has a direct role to play in these properties, so that's why we are measuring it on real time just to see how free drainage is impacting all these properties. Other than that, we'll be collecting data for refiner, which will include the refiner consistency, refiner inlet power, effective power and the refiner load. Other than that, we'll also be measuring data for moisture. So apart from that, we'll be also measuring data through the sensors, which is pH, conductivity, TSS and temperature for the whitewater. Since whitewater properties are of prime importance for an RDA program, so we'll be calculating this data or measuring this data through the sensors. Other than that, we'll be also collecting data through an offline mode, which will be drainage rate, headbox consistency, degree SR, charge demand. Since these parameters, help us to identify the machine behavior, so that's why we'll be measuring these collecting this data through an offline mode. Now, once we have all this data through different sources, through our virtual sensor, we'll be basically predicting FPR and FPAR. Now, once we have all the this KPIs, we'll be controlling the dosage of the coagulant, flocculant and the microparticles, which we generally use in the retention and drainage program. Now coming to the once we have developed and implemented the model at site, so one of the key observations that we had was the whitewater TSS variation. As you can see in the graph also, there is a significant decrease in the TSS variation, whitewater TSS variation with the implementation of the model. And once this, if there is a reduced variation in the TSS, it will also lead to a more stable retention on the paper machine, which will eventually, improve the stability of the machine PPR varies on the machine, it will eventually also lead to variation in the drainage rate and moisture that is leaving the forming moisture of the sheet, that is basically leaving the forming section, which will eventually impact the web breaks on the machine. Other than that, this is the KPIs which we are also have predicted. This is FPR and FPAR. As you can see, there is a significant increase in both the properties with the implementation of the model. Now coming to the drainage rate, so this is something that we are not predicting on a real-time basis as of now, but we are working on it. So we have just collected this data through an offline mode just to see how this prediction of the KPI, that is FPR and FPAR, and the prediction of the chemical dosages has impacted the free drainage. As you can see, there is a significant increase of around 15% in the drainage rate, which will also impact the steam consumption that is on the dryer section, and also reduce the vacuum load on the machine. So this is basically the added benefits of improving the drainage rate on the machine with the help of an AI-based model. Now coming to the conclusion, with the implementation of this AI-based model on a retention and drainage program, a regular retention and drainage program, it has given us significant benefits in terms of cost savings and energy consumption. And also, we can, as AI has a capacity to handle huge sets of data, we can implement this model in different sections of the paper machine. Maybe in the bleaching section to optimize it, maybe in the refiner management, maybe for strength improvement, which will help us to predict things in real time, and also help us to prevent the deviations on machine, which will improve the stability of the machine and also optimize the process. Thank you. This was all.